everyone, next up is working on the script for actually making the player move. So I'm just going to make sure that my player node is active, clicking on the new script button. I'm going to leave all the defaults. I could theoretically choose a template with some basic movement already, but I want tank controls, which this is not going to be, so I am going to leave that unchecked, and this is going to give me better control over my actual movement later on. So the path is just fine. If I wanted to move it into the script folder so all of my scripts are together, I could. Or if I want to leave it in the player folder so that everything for the player is in place, that's completely fine. Really a matter of personal preference. And I'm just going to create. All right, now I've actually made the script already, so I'm just going to copy and paste it in, and then I'm going to walk you through what the script is actually doing. All right, so we have the character body 3D class that's being extended to the script or to our player. Whatever this node is right here is what the class should be. So our character body 3D. You may notice when you hover over the different methods and properties and classes, you'll be able to get some extra information about it, which is super helpful. It's a nice new feature. All right, so we have, you can see several export variables. I'm just going to go into the full screen here and zoom in a little bit more so that this is more clear. All right, so we have several export variables which do show up over on the inspector, and they'll show up as soon as you add them, which is super helpful. And so we can change them in the script, or we can change them in the inspector so we can test some things out while we're playing the game. So these are all global and are available for the entire script. So first up, we have move speed. This is a float value, and I just have 14.0, so decimal, as a starting value. A variable to represent the turn speed, so how quickly the player rotates, 4.0 for now. A variable to represent how high the player can jump. I have this at 100. That may be a little high. We'll see. I can always come back and change it. Time up is going to be a variable that represents the time the player spends jumping upward, so the amount of time they're moving up during the jump. Time down is going to represent the amount of time that the player is falling back to the ground during the jump. So after the player reaches the top of the jump, as they start coming back down. So they're accelerating, so this time is a little bit faster. Next up, we have a number to represent the rotation of the jump. Adding just a little bit of a rotation, whether that's literally here in the code or even in an animation, can help the jump feel a little bit more realistic. Then we have an onready variable, and so this isn't exported, so it's not available in the inspector, but because it's onready, it's ready when the scene first loads. So as soon as the player is available, this variable is available. So the jump velocity, and you can see it's using both the jump height and the amount of time up in the air to impact the velocity. Then we have another onready variable that represents when gravity is having a higher impact. And there's a formula here that's using the jump height and the time up in the air. And so this is just when the player has started falling, and so the gravitational force is unbalanced. So gravity is really having more of an impact. Then we have a low gravity impact. So whenever the player is not falling, then gravity is being balanced out by other forces, so it's having less of an impact on the player. And again, the jump height and the time down put into a formula to represent that. And our last variable is just a global variable. It's not onready, it's not exported, but it's available for everything. It's a vector 3, and this is just set to 0. All right, next up we have our physics function, and this is a default function that's available. and it's using delta as a parameter so that it's making sure that the speed is consistent between different devices or operating systems. So we have a couple of variables that are specific to this function. We have the move direction, another vector3 set to 0, and then we have a turn direction, which is just a float for 0. So at the start, the player is not actively moving or turning. Those numbers are both 0. Next up, we are setting the move directions z vector using the input for moving back and moving forward. So when you have an input get action strength dash the input dot get action strength, that sets whatever the first action is or the first input is to a -1, and it sets the second input to a +1. So this is just setting the z move direction to either a negative or +1. Turn direction is pretty much the same thing. It's just setting the turn left input to a -1 and the turn right input to a +1. Next, we're setting the rotation degrees, which is a default property. So we're setting the Y rotation, which is our vertical axis, to keep adding the turn direction multiplied by the turning speed. So whatever this result is keeps getting added to our Y value for rotation degrees. Now we have our target velocity variable again, and instead of leaving it at 0, we are going to be setting it to the z move direction multiplied by the global transform basis for the z-axis. And this is what gives us our orientation right here, multiplying by the z basis for the global transform, and then multiplied by the movement speed. So this is just going to be representing the vector3 for the movement speed, direction, and orientation. So all three of those things in one. And next up, we're setting the target velocity for y. And this is specifically going to be helpful when our player is jumping in the future. So plus equals, so it's adding to the y velocity. Gravity impact is a function we're going to be creating a little bit later, and we're multiplying that by delta so that it's consistent across operating systems. Next up, this is going to be our jumping action. And so is on the floor is a default method. And so if the character is on a surface and the input for jumping has been pressed, then the target velocity for the y-axis is going to be increased by the jump velocity. So this is just setting our target velocity. It's not actually creating any movement yet. Now, velocity is another default property, and we are setting our velocity to be the same as whatever the target velocity is. And just so you're aware, velocity is already using delta, so we don't need to multiply the target velocity by delta. And then we have a move and slide. So this is taking our velocity value and actually moving our character body 3D or our player object. And if our player hits another surface, it's going to slide in response. Last up, we have a call for another custom function for setting the jump rotation that we had a value for up here at the top. All right. So next we have our custom functions. We have 3 of them. I'm going to come back to this last one in another video, so I'm just going to minimize that so it's sort of out of the way. But we have a function for setting the jump rotation. And so what this is doing, it's using is on floor. So it's recognizing is the player on a surface or not. So if it's not on a surface, and the velocity is less than 0, Then the player is in the air, so it's going to be rotating our pivot from the x-axis with a negative number. And you can see a bit of a formula over here controlling how much it's rotating back. This is being impacted by the jump rotation, the velocity, and the jump velocity. So several things, and pi. So just a reminder, when you write pivot, all that is doing is calling the thing with the name. And you can actually just drag from the scene tree into the script wherever you want to call that, or you can type the name. It'll work either way. But the $ just represents this is going to be a name of a node or a path, and then you have the name following it. All right, so if the player is not on the ground and the velocity is less than 0, the player is going to tilt one direction. And if the player is again in the air, but the velocity is over 0, the player is going to tilt another direction. And you can see that the speed of those things is going to be a little bit different because of the jump rotation being divided over here. If neither of those things are true, then the rotation for the x-axis is going to be set back to 0. And then the last function that we're covering today is a custom function for the gravity impact. And so this, again, is just helping us simulate how gravity is impacting the falling player differently than the player at rest or when it's just moving along the ground plane and not actively in the air. All right, I don't think I finished writing that comment, so I'm just going to delete that. All right. So if the target velocity is under 0, then the player is falling, and gravity is an unbalanced force at this point, so it's going to have a high impact. Otherwise, the player isn't falling, so other forces are balancing out gravity's force, so there's a lower gravity impact. And I'll come back to the is-player colliding function another time, because that really doesn't have anything to do with the movement functionality that's going to be part of our winning and losing scenario going forward. So I'll come back and explain that later on. All right, from here, I want to make sure that I save the changes to my script with Command S, and I'll be back in another video.